In this video, you're going to learn about the different IoT architectural approaches that you can take when developing an IoT solution. You're going to learn how to leverage edge computing, how to select an IoT gateway, how to select communication protocols, security mechanisms, and you're also going to learn how to select an industrial IoT platform and much more. My guest to help impart that knowledge is Rick Bullota. Rick co-founded ThingWorx, which was later acquired by PTC. ThingWorx was the first and currently is one of the best industrial IoT platforms. Rick previously served as partner director at Microsoft, where he helped define and drive Azure IoT strategy, and he was also previously CTO at Wonderweb, a leading global provider of manufacturing operations software solutions. He was a vice president with SAP Research in the areas of future manufacturing and the Internet of Things. Rick was also the CTO and co-founder of Lighthammer Software Development, a company developing software products targeted at the manufacturing industry. He currently serves as an investor, advisor, board member, and mentor in many industrial IoT startup companies. Welcome to the 4th Generation podcast here on Industry40.tv, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. Now, here's my conversation with Rick. Rick, welcome to the show, and thank you so much for joining us today.
Pleasure to be with you.
Okay, yeah, so we'll just jump right in.
Cool.
So now, in the past decade or so, we've seen industrial IoT architectures change from simple cases of just collecting sensor data and sending it to the cloud to like a wide variety of scenarios. Now, what I want to know is what architectural patterns are currently available as options for implementing IoT solution.
So, I mean, broadly, what's interesting is when we talk about industrial IoT, I always ask the first question is, are we talking about all of the industrial applications of IoT, or kind of the narrow definition, which is manufacturing plants, power generation facilities, and that certainly dictates what architectural options make sense. In the broader definition, you've got everything from I call it if there's such a thing as traditional IoT, connected fleets of assets that are typically connected for remote management, remote monitoring, almost like in a way, the original definition of SCADA, right? Where we would monitor sensors in oil fields and things like that. And then kind of the Industry 4.0 type definition, which is focusing on those, not just the assets, but the processes that are going on inside, these industrial facilities. And quite honestly, they're two radically different architectural needs, implementation models, different kinds of data. Even today, 90 to maybe as much as 98% of the latter case, right, inside the plant systems are still on-prem. That's just the nature of how they've been deployed. We call it the edge now. It's not on-prem anymore, but whereas probably the complete opposite, 99% of those connected fleet scenarios are kind of cloud to device. So the short version is it really is all of the above. Depending on the use case, one architectural approach or another will make the most sense. Another one that's I think often overlooked is the location of the site itself. If the data has a very limited connection to the outside world, but it's very data intensive, that may lend itself to a bit more edge processing. Whereas if you have virtually limitless access and reliable networks, reliability being a very important piece, in general, the cloud doesn't go down, right? But there's many things along the way that can cause problems, not just the cloud itself. So availability, performance, latency, all these kinds of things matter quite a bit as well.
Okay, yeah, I totally agree there. I mean, like edge computing seems to make quite a compelling case, particularly for manufacturing companies. Now, what I want to know is, when implementing an edge solution, like an IoT solution, to what extent should workload processes be assigned to the edge as compared to the cloud?
That's a great question, a very important one too. Also very specific to each implementation. I used to joke about the ilities, right? The availability, reliability, all of the kind of the things, scalability, all the things that we want in our applications. We have to look at each, at each use case and decide, is it, if I have to have very low latency, if I have to have nearly 100% uptime, as I said, it's not like the cloud that goes down or the computer on site. It's all those many elements of failure in between that can cause us problems. So mission critical workloads, tend to be as close to the hardware as we can. I mean, if you think about, let's even go really talk about the edge. A PLC, right? 80% of your code in a PLC is typically error handling, safety, all those very, very mission critical things. Highly available hardware, directly connected to the I/O. And then as the mission criticality changes, as you move up the stack, then you can determine, you have a little bit more flexibility. Performance certainly matters quite a bit, right? If I'm increasingly, for example, we're starting to see more and more applications of video analysis and audio analysis and signal analysis being pushed out to the edge, where it used to have, require moving a lot of data to the cloud, crunching some stuff. Now that's becoming very feasible to do at the edge. Human interface, right? Our HMIs and our SCADAs, it doesn't make a lot of sense to me to move a bunch of data to the cloud and then bring the visual experience back. So I think that's another part, is where are the consumers of that data or the users of that data? A number of years ago, my first company was a company called Lighthammer. And basically what that was all about was initially remote visibility to that data, whether remote meant in an office, 100 meters away, or did it mean, someone across the country or across the world. And what we noticed, we started looking at usage patterns of who was consuming the data. Example would be from a historian, right? Lots and lots of data collected very quickly. And we found that the people that are using the most data the most frequently tended to be co-located with that data, right? So that sort of lends itself to an architecture where all that communication happens locally, as opposed to sending massive amounts of data back and forth to the cloud. I think the analytics world is kind of changing things a little bit. So I talk a lot about kind of the hot path data, right? What's going on right now. And then the kind of cold path or warm path data, where you archive it, you do analysis on it. We've seen a lot of people start to move that data into cloud architectures. I think that's a byproduct also of the analytic tools and the AI and machine learning tools we have today tend to like to have a big data lake. They're not really well suited to go to the source systems directly. So that's probably influencing adoption of cloud solutions as well.
Okay, yeah, that's very interesting. Now, as you might be aware, I create quite some content on LinkedIn there, and I get like quite some feedback from individuals and companies wanting to implement IoT solutions. And one of the most common questions is, what device platform or IoT gateway should we use for our IoT solution? Now, what would you say are the factors to consider when selecting an IoT gateway?
Well, that's a good question. And I think the first foundational question is, what's the communication technology you're going to use? So if it's, that may, indirectly dictate, if I'm just going to be using existing, broadband or fiber backhaul to the cloud, in essence, any kind of, industrial compute would be fine, right? Pretty much off the shelf PC or, industrial dedicated device will be fine. Increasingly, we're seeing a lot more Linux on the plant floor. If you remember, you roll back 10 years, we were probably 99% Windows. Increasingly, we're starting to see Linux OSs in some of these devices, but it's going to be more an issue of, are you using a cellular backhaul, a company most recently might be implementing, for example, like a 5G private network. It's very early, satellite backhaul. Second question would be, how do you want to implement high availability? There's in essence two approaches to that: a software-based approach with multiple instances, multiple boxes, and then in the industrial world, we've traditionally taken a hardware-based approach, highly available hardware with redundant power supplies and again CPU and memory and all these types of things. So those considerations as well. Once again, we're kind of getting back to the IoTs, right? Availability, reliability. But honestly, I think the software is going to matter more. The gateways for I'm not going to say they're commoditized, but they're more interchangeable than they have ever been.
Oh, okay. Yeah, that makes quite a lot of sense there. Now, one of the things that I really consider to be a good design practice when you're putting together an IoT solution is how easily you can add components to that solution. I mean, particularly with the industrial landscape, where we've got like a variety of systems. Now, what sort of integration mechanisms should people use to sort of like simplify that onboarding process?
When you say, so in that would be like physical devices or more, when you're trying to integrate a new source of data, or, I mean, a lot of it depends on whether it's legacy, in which case the integration mechanism is largely dictated by the capabilities of that legacy device. And unfortunately, in our world, as you know, most everything is legacy, right? It's 10, 20 years old. I think this also ties back in with that kind of connected fleet scenario where you might be using, a cellular network. So that the act of bringing on a new device is provisioning it on communication, provisioning it in your cloud system, provisioning any software systems. So that's kind of there's actually some best practices that are available that each of the IoT cloud vendors have to help with that. Sometimes it's even, it's not just the provisioning, it's the device management, keeping them up to date. It's being able to remotely disable a rogue device, for example, those kinds of things. But within our four-wall kind of solutions, within the a manufacturing plant or utility, power generation facility, that's really tends to be so specific to what that system is, what communication protocols and supports. The only consideration I guess I'd add to that is increasingly for less mission critical, even some mission critical software applications, the idea of provisioning is no longer you had to request from the IT department some physical hardware, a server blade. Now it might be provisioning a virtual machine in some kind of virtualized computing infrastructure that could be on site, could be in your company's data center. So the idea of provisioning capacity now is very different than it was, a few years ago. Oh,
okay, yeah, that's quite interesting. Now we're going to move on to one of the hotly contested issues, protocol selection. I know then there might not be a straightforward answer to that, but what would you say are considerations that one should take when selecting an IoT communication protocol to use?
Sure, great question, and it's also a complicated one, in that it goes back to this I call it the last mile or the last foot. We're basically dependent on what the device communicates, the sensor, the controller, the historian, whatever that source of data is. We're generally dependent on whatever protocols it supports. And as you well know, every PLC vendor has their own communication protocols, proprietary APIs for many of the software systems that we use in our industrial environments. But then when you start to go, how do you connect these systems together as peers or connect them to the cloud? Again, today, I think, unfortunately, those actual protocols tend to be very specific to the IoT cloud vendor or industrial cloud vendor. At some level, it's almost always a TCP-based protocol. And I know one of the topics you wanted to cover is architectural patterns, request response versus pub sub. We'll touch on that in a minute. But I just don't see yet a lot of standardization. even companies that use, for example, something like MQTT as their bridge from the industrial side, or excuse me, the edge side to the cloud, apply it in very, very different ways. Different ways they use these underlying protocols. Really, they become just a way to send packets back and forth almost, rather than semantically interesting. Then you've got OPC UA. Again, OPC and OPC UA, at some level, you still have to talk to the physical device. We've got that, Tower of Babel that we need to deal with for that last bit. And then natively on the other side, once again, I still see a lot of people who deploy something like OPC or OPC UA, who once again do yet another protocol translation to get it into their cloud system. Or quite commonly, sometimes they'll do a translation to take perhaps a very technical identifier out of your control system and turn it into a friendlier name that you might want to use in a IoT cloud or a digital twin model or data analytics.
Oh yes, yeah. Maybe let's touch on the issue of like the two main IoT communication patterns, which is the client server model and the publish subscribe pattern of communication. What are the key pros and cons for each that you see there?
Not surprisingly, it's another all of the above scenario, right? Where there's perfectly good use cases for each. Things like let's go down again at the lowest level. Sometimes many of these devices exclusively support, and I would maybe combine with client server more request response, right? That's kind of that side of the equation. So that's how a lot of those protocols have typically worked. You're polling, you're asking the device for something, you get a response. So at some level, we still have a lot of that because the devices need to. Similarly, when we're doing things like invoking, making a request to set a value, or we're asking some querying our historian, those fit the client server request response pattern very well. When we're looking at more real-time data, where I'm interested in new latest values for telemetry, or I'm interested in subscribing to some pattern of events or alarms, those tend to fit the pub sub model very well. MQTT, OPC, many, many others. One of the challenges there is just basically, once again, you've got to map all these other kind of systems into this namespace, whether it's your OPC namespace or your MQTT namespace. But I'm a big believer in pub sub and event-driven or exception-driven applications. Typically a lot more efficient. You can cache late. If 500 people all want to look at the most recent temperature out of a storage vessel, there's no reason we should have to read 500 times to that sort of system. So in a traditional kind of request response, imagine that we're loading the system up with 500 requests every 10 seconds. That's kind of silly. So a lot of times what we'll do is we'll put some form of broker in the middle, right? That caches that data. The other advantage to that is if you look at the other way, imagine that data is in the cloud. It's actually surprisingly difficult to do pub sub or exception-driven communications without a persistent connection. You need to keep a pipe open, right, to the cloud. Yet many cloud architectures are not really well designed for keeping a pipe open, right? They're designed for a website that loads a page, and I'm oversimplifying. But this is where there's some complexity in implementing things like MQTT and other protocols in the cloud, because it does require a different way to manage those many connections. So architecturally, it brings some of its own challenges with it. And these are all, I think the other benefit of bringing a broker into the middle of some sort is it gives you a place to aggregate data from multiple sources, which is extremely valuable. Whether you want to call it a digital twin or whatever you want to call it, it's still a valuable ability to create kind of a more 360 view of your assets and processes. The second thing it does, which I don't think gets fully appreciated sometimes, many of these source systems have little or no security. If you can plug into them, you can communicate with it. So the ability to kind of use that broker tier as your security and access control tier is also another benefit.
Oh yeah. Well, speaking of security, I mean, well, we should go without saying that security really needs to be an integral part of an IoT architecture now. What techniques should be used, you believe should be used for securing data that is both at rest and also in transit?
So let's start with a lot of the don'ts, the do's, and if there's a book that just came out. I highly recommend it if you haven't read it yet. It's called Countdown to Zero Day, and it's basically an analysis of the Stuxnet attack, and in very granular detail about how it was executed with USB keys and the layered complexity of this malware and how it integrated with the PLCs, how it masks itself. That, if you read that, you will immediately identify 10 of the top don'ts, right? Okay. Simple things like using default passwords or storing hard-coded passwords, or protocols that have no encryption, protocols that have no access controls if you're physically connected. So, I mean, I guess many of those things are quite obvious, right? But they still happen a lot. I mean, you go to somewhere like, there's a search engine, Shodan, that's the search engine for vulnerabilities. It's kind of frightening how many of those systems are just readily exposed. Other simple things that that aren't necessarily obvious. It's not really necessary. Let's imagine that I have a system in an industrial facility that I want to expose to the outside world. The least secure thing you could do is give it a public IP address, right? I mean, that's just insane to make it public. So firewall technology, or exclusively using outbound connections from those systems to the cloud. It's not foolproof, but because they can be spoofed and things like that. Certificate management. You'd be amazed how many companies have turned off certificate verification, right? Because they don't want to update their devices at the edge with certificate fingerprint. That's just bad hygiene, right? I understand it's difficult and it's hard, but you are opening yourself up to be, man in the middle. It's all kinds of attacks that create complexity. And then security is like, again, we have so many systems that inherently are insecure. Physical security matters. Air gaps, communications, physically how you wire these things up. Right? If it's easy for someone to plug a Ethernet cable from the IT network to the plant control network, man, that's a problem. So physical security and air gaps. And then lastly, the part that I don't think gets talked about enough is the application level security, right? Different people have different roles and functions. A technician may need to get at very low level access to some of these systems and configure them. Or based on my business function, I may need to, access certain things and others. Our systems historically have not been good about very granular access controls. You kind of have access to everything or nothing. So again, I think this is where kind of an intermediate broker or middleware or something brings a lot of value. Is it can. As long as you've implemented it such that the only way to get to those source systems is through that broker, then it can become effectively a special kind of firewall in a way, with more application level security in there as well. I'm a big believer in that approach.
Yeah, that's very interesting. Very interesting insights. Now, as you are well aware, there's like thousands of cloud platforms. Including big cloud like your Azure and AWS. Now, given that situation, how would one go about like selecting the platform that's most appropriate to what they need to achieve as far as IoT is concerned?
I wish there was an easy answer for that one also, but it's it's borders on a religious or political discussion sometimes, right? Mm-hmm. A lot of times, so you've got the cloud vendors themselves. I mean, I won't oversimplify, but there's not too many big cloud vendors out there, right? There's not any longer. Secondly, you might choose to use the IoT platform provided by those vendors, or you might choose to utilize a third-party platform that may be hosted on one of those general purpose cloud vendors. So oftentimes you don't even know what the underlying cloud infrastructure is. You have to consider geographical coverage, right? Do they have data centers near me that can deal with the latency considerations, availability considerations, data residency, and all those kinds of things that are very, very important. Do they understand the industrial use case? Are they priced to deal with the massive amounts of data ingestion that an industrial process and industrial equipment might generate? Pricing is, it's something a lot of people, quite frankly, it can be very difficult to calculate in advance what your cloud costs will be. I would also consider, do they have some unique intellectual property around analytics or some other capability? Increasingly, it's becoming a multi-cloud world. I mean, that's just the nature of, you might be running Salesforce for your CRM systems, some hosted SAP somewhere for your back office systems, some analytic cloud or manufacturing intelligence application running somewhere else. So again, good security hygiene on how you connect those two together, or three or four, as the case may be. And I think we have to be thoughtful about what workloads to move to a cloud in the first place, right? Because sometimes the pendulum swings too far one direction or the other. So being thoughtful about cost being one of those, right? Data ingress tends to be one of the most expensive parts. So do we really need to move all that data up? In many cases, the answer is yes. Historically, I would say, and this is just opinion, take it at face value, Microsoft has had a much stronger presence in the industrial space. That's the way it's been, both from an outgrowth of success of Windows and industrial, but other cloud vendors certainly have viable solutions as well, and certainly a number of third parties do as well. So short version is pick your applications that you really need to use and the capabilities you need to use, and then then choose the cloud vendor accordingly. A lot of times, to be honest, companies have already established a deep relationship with one cloud vendor at the IT level, and you might be kind of forced into, for sometimes good reasons, but that choice may have already been made for the OT people as to which cloud vendor they're going to utilize.
Oh yeah. Well, maybe as a follow-up to that question, there are cases where like maybe companies might want to migrate their solution in between some platforms. Yep. So obviously that would require that they actually have a solution that is not locked into that platform. So what architectural approaches should one take to sort of avoid being locked into a single platform?
That's a great question. That's a topic I'm personally very passionate about, in that having built a couple platforms over the years, I was always trying to protect my customers from that, right? And it's not just protecting them from cloud dependence, it's what data storage they might be using. Some new evolution and new capability comes out. How can I allow customers to leverage that? So it comes down to me to abstraction and extensibility. Abstracting away the fundamental parts of your application. I need to store and retrieve time series data. I need to cache real-time values and share them over a pub sub infrastructure. I need to route the workflows to my backend. Think of it abstractly, and then find out in each of those cloud vendors. Of course, there's going to be some rework required inevitably as you move between those. But as a third party, this is where perhaps the benefit of third party or intermediary IoT platforms can be very helpful, because they've taken that into consideration. Not all of them. Some are very tightly bound to one cloud vendor or another. But considering, again, that abstraction and extensibility, I believe, is kind of the core of all of it. You brought up examples like Geo, I think in one of your questions when we were talking earlier, lifting applications across geographies, right? Well, I might not have that cloud vendor, or might not be the ideal one for this particular region of the world. You've got a lot of companies, for example, which are, take one cloud vendor approach in China, another in different parts of the world. You have to be prepared for that. It's not just what's technically best, it's regulatory considerations, it's practical considerations. And increasingly, I don't see a lot of companies or vendors doing a really good job to help customers that have a distributed cloud solution, even if it was all on Microsoft or Amazon, but it's multi-region. There's still a big problem in how do you deploy applications across those? How do you get a holistic view of all the data that's across that wide geography? So there's still a lot of work that the cloud vendors can do as well to make not just, I think they're all being fairly good about portability. Most of them give you a way to export your data, no matter how massive it might be. It does get to the point when you look at the size and scope of industrial data, you get to a point where there's just so much gravity around that data, it becomes very difficult and expensive to move. So lock-in sort of happens sometimes on its own. But yeah, abstraction and looking at potentially third-party solutions that sit on top of the generic cloud infrastructure or even the other IoT clouds. And that's just another pattern that's happening a lot as well, as companies have focused more on the application layer, right? And whether it came in through Azure IoT, ThingWorks, AWS IoT, an MQTT broker, and Google Cloud, who cares? We're an application level platform that lets people utilize that data in different ways: visualization, AI, enterprise integration, things like that.
Oh, interesting. Now, based on the argument that you just put forward, I would like to believe that we're going to see a lot of solutions being built like in a distributed fashion. So it means there's going to be a whole lot of cloud-to-cloud communication. Do you have any best practices as far as cloud-to-cloud integration is concerned? What should companies look out for?
That's great. That's a good question. I mean, one of the big so let me give you a kind of a classic example of cloud to cloud in the broader IoT is where a vendor of some communication infrastructure, a low power wireless network, a satellite connection, even a cellular network of IoT devices sometimes. The device management, the device provisioning, and the raw movement of data and messages may be all encapsulated in that vendor's cloud, wherever that might be. It could be in their own data centers. It could be on one of the big cloud vendors. But I almost like to think of those as just one big device, right? It's one big device that has a lot of data. And how can I efficiently link those two together? That's where a pub-sub model is absolutely essential. To try and move that much data in a request-response way, or let's just say it doesn't necessarily need to be pub-sub per se, but an exception-based movement, a fire hose of information and interesting events. This is actually where the vendors themselves have some responsibility to expose data in an easy way to consume. Interesting events, you should be able to know when a new device got added or removed. You should know when new data or events has arrived, a conduit. But once again, I think it starts to become increasingly obvious to a lot of people that that IoT cloud, that third-party IoT cloud, and the device data is just one part of the solution, right? All the information about an asset goes way beyond the data coming in from the device and its sensors, its service history, all kinds of other, how it was manufactured. All this other information needs to be kind of brought together to really get the maximum value. So that's why I kind of like to think of integrating with another IoT cloud. It's just one giant, one giant PLC, right? or one giant device that I need to integrate with. Oh,
interesting. Well, we have already touched a bit on the issue of the fact that there's some services that may not be available in certain geographical areas. So I've always wondered how that really affects your architecture. You as an architect, how does it affect you in putting together a solution? So yeah.
Yeah, I think the three big things that it affects directly are how you deploy applications. If I want a consistent application across the globe, yet I am running it in different data centers, let's be clear too, it's not just a problem with the applications we build collectively. The cloud vendors themselves don't have necessarily consistent deployment of their own services across the globe, right? If you look at some new, XYZ cloud vendor comes out with some cool new thing that does vibration analysis on equipment, and that's service in the cloud. It doesn't mean it's going to be available in every region. It doesn't mean it's going to be available in every region in some specific time frame. So even the infrastructural pieces that we use will dictate where we run that. Obviously regulatory, when we start dealing with anything in the health or medical domain, even, again, regionally, it can go much, much broader than that, where you have restrictions on where the data can move. What it does create a big complication with is how you create that holistic view, right? If I want a global view, if I want to do global analytics, that becomes increasingly difficult when the data is fragmented. So if we take a page from learn a lesson from the healthcare industry, the concept of personally identifiable information, right? Where we may, maybe it's permitted to bring some somewhat anonymized information about those assets and processes together in a data lake in one geography. Again, it's very specific to regulatory issues and things like that.
Oh, interesting. Now, correct me if I'm wrong, but what I foresee is a situation whereby manufacturing companies are not going to go like all in with the external platforms. I believe we're sort of going to see like a mixture of private sort of kind of cloud and public cloud. Could you please compare for us between public cloud and private cloud as far as benefits to a manufacturing company is concerned?
Sure. So, there's a fine line between what a private cloud is and private cloud-like stuff, right? So go back to the earlier example where a customer may have a data center and they're running, virtualization infrastructure, or some common data services on their hardware. They may be doing that, with more of a virtualization vendor or a database vendor, or they may be increasingly, some of the cloud vendors now let you bring cloud-like functionality to the edge. They have hardware partners that'll build you a rack that you manage very much like as if you were running Azure or AWS or something like that. So that line gets kind of blurry what the difference is between them, but it still comes down to there are a great example I think would be like governmental cloud, right? We've got in the national security industry or defense industry, each of the big cloud vendors has already built kind of segmented clouds for them. A lot of businesses still manage certain parts of their infrastructure because they just believe that data can't risk flowing outside the boundaries for a variety of reasons, whether they're real or imagined. And then all the illities we talked about earlier, right? I need availability. There's a lot of debate and discussion about whether private infrastructure and private clouds are more reliable or more secure than a public cloud. Because the question, here you have a group of the cloud vendors live this day in, day out. They're always trying to improve their uptime, their service, their security. Do you have that same capability, with a private cloud? I don't know. That's not really my core area of expertise, that kind of infrastructural stuff. But I think really it comes down more to where does the application need to run? What's the best place for it to run? And can we get some of those good cloud-like capabilities, even if we're running it in the edge, in the data center? Like I personally would love to see edge infrastructure start to bring more cloud-like capabilities too. That particularly, we're starting to do more things with these applications. Performance is suffering. Instead of getting a bigger box, put more boxes and enable people in the manufacturing world, or excuse me, the plant side of the world. Manufacturing's a big thing, right? You have design, right? You have designing products, selling product, service. But within that plan environment, we grew up out of the kind of the client server world, or even worse, the monolithic app running on one box. If we can get tools from the cloud vendors and infrastructure from the cloud vendors that lets us get all the goodness of cloud scalability, high availability, all that stuff, I think that would be kind of cool, right? But we also have to make it easier for developers to develop applications that leverage those capabilities without having to be experts in, you know, designing for a cloud architecture. That's, to me, a super exciting opportunity for the cloud vendors themselves, is to rediscover the edge.
Yeah, it certainly is, and makes quite a lot of sense. Now, Rick, I mean, yourself, you've put out quite a lot of successful IoT software companies. Now, as a last question, is there anything that you're currently working on, or anything that you want to bring to the attention of the audience?
Well, a lot of the things that I'm doing, you know, I'm a lifelong learner. I'm always trying to learn new technologies. My COVID project was to learn data science and Python and all that stuff. But a lot of the companies that I'm working with these days are in the AI space, applied machine learning, whether it's edge-based stuff to take vibration and audio and, you know, imagery and turn them into meaningful industrial applications. There's just so much potential for that. I call it meta sensing. It's an area that I've always felt would be super powerful. And then similarly, some companies I'm working with that are applying AI and machine learning on the cloud side. What's interesting, though, is a lot of the companies in that space are very, very focused on the assets, the machines, and, you know, their uptime. An interesting amount of lost opportunity or missed opportunity is applying those same techniques to the processes themselves. So that's an area that I'm spending some time on these days and really intrigued by.
Oh, that's some really interesting stuff. Now, Rick, that brings us to the end of this discussion. I really enjoyed speaking to you about everything IoT. Now, I wish you all the best in your future endeavors, and thank you so much for joining us today.
Thank you for having me.
Thank you.